In section 1.4, we're going to be working on writing equations and inequalities. So our learning objectives here are how to translate verbal phrases into equations, algebraic equations, and algebraic inequalities. Now remember, equations, an equation, part of our key vocabulary is an equation, will be one or more, or two more or more algebraic expressions connected with an equal sign, so the equal sign is going to be part of that. An inequality would be the same idea but connected with an inequality sign, so we also have all of these. So we have less than, greater than or equal to, less than or equal to, right? So these would be for the inequalities, and equations have equal signs. We're also going to, as we go through, talk about what is an open sentence, what's the solution of an equation, and what's the solution of an inequality. So keep in mind that these are going to be, a solution of an equation is going to be a value of the variable that satisfies the equation. And solution of an inequality would be value or values of the variable that satisfy the inequality. So again, repeating what I basically just went through, equal to means the same as, less than is fewer than, less than or equal to would be expressed as at most or no more than, greater than would be more than, greater than or equal to would be at least a value or no less than a value. And then also to remind you with product would be multiplication, sum would be addition, difference would be subtraction, ratio or quotient would be indications of division. Okay, so if we want to have the sum of 12 and the quantity 8 times the number k, so the sum, that's going to be addition, and 8 times, that's going to be multiplication, is equal to, so we're going to have 12 plus 8 times the number k, which would be 8k, is equal to 48. The product would be multiplication, of 4 and a number w is at most, so it could be 51 or less, so it's going to be less than or equal to 51. So we'll have 4w is less than or equal to 51. Okay, if we want to check possible solutions, that means I'm going to take the supplied value, I'm going to plug it in for my variable and check to see if I get a true statement or an untrue statement. So if I have 12 divided by 3 minus 4 is equal to 4, well, 12 divided by 3 is 4. 4 minus 4 equal to 4. Is 0 equal to 4? No, it is not. So this is not a solution. So when I plug the value in and I end up with an untrue statement, the value is not a solution. If I end up with a true statement, it is a solution. So if I have 9 minus 3.5 is less than 6. Well, 9 minus 3.5 is 5.5. Is 5.5 less than 6? Yes, it is. So this is a solution. Continuing on, we want to write an open sentence. And then check whether 3.5 is a solution of the open sentence. So if you go back to some of the other things we wrote, when we were writing equations and inequalities, we're writing open sentences. 2 less than the product, 2 less, that's subtraction, the product of 3 and a number x, so that's 3 times x, is equal to the sum, that's addition, of x and 5. So 2 less than the product of 3 and the number x. So there's the product of 3 and x, 2 less would be minus 2. 3x minus 2 is equal to the sum of x plus 5. And then what I would want to do is I'd want to simplify this, right? And if I simplify this, that's going to be going ahead and getting my variables together and my like terms together. So that's what I want to do, is get the like terms together. So I will subtract an x from either side. I'll add 2 to either side. 2 times x is equal to 7. So then check whether 3½ is a solution. 2 times 3 1/2 is equal to 7. Is 7 equal to 7? Yes, it is a solution. And finally, by the time we were doing this problem, I'm sure by the time you saw 2 times 3½ is equal to 7, you could see that this value was equal to 7. Maybe back here when you looked at 2x and that the value we were plugging in was 3½ you knew it was 7. Okay, and that's what we talk about using mental math, steps that you do in your head that don't necessarily need to be written down. Some equations are simple enough to solve using mental math, so really what we're trying to do is answer the question. We should use as much mental math as we can and still maintain accuracy. So sometimes we get ahead of ourselves in terms of using too much mental math, but you also don't need to be so rigid and so stuck into things that you spend more time than is necessary to solve the problem. So let's look at this problem. The last time you and 3 friends went off to a mountain bike park, you had a coupon for $10 off and you paid $17 for 4 tickets. What is the regular price of 4 tickets? If you pay the regular price this time and share it equally, how much does each person have to pay? Well, I had a coupon for $10 off and we paid $17. So I know that if I wanted to write 4 tickets, if I want to write a verbal model, and the value of the verbal model is that it lets us make sure that we understand the situation. So 4 tickets is equal to $17 plus the $10 coupon. Or I could write it another way. I could write it as $17 is equal to 4 times the amount of tickets minus $10. Right? So as I said the next verbal model, you'll notice I wrote it as an equation. So if I now want to solve the problem, I know I'm going to add 10 to either side. I'll get $27 is what the 4 tickets cost. And if I divide 27 by 4, what's it going to be? It's going to be, right, $6.75. Okay, so you should use as much math as is necessary to solve the problem and still be accurate. I would still want to check this, right? If I multiply it out, 4 times $6 is $24. And then 4 times 3/4, 4 times 3/4, the 4's cancel and I just get 3, is $3. 24 and 3 is $27. So check my work, I'm good, and we're going to move on.